Hello friends, welcome to this new video which is a continuation of the interference. So now, as I have told earlier, we are going to continue with the small concept of energy conservation in interference. So, in absence of interference phenomena, the resultant intensity due to the two waves having same amplitude A must be, if we consider the resultant as I, so that will be equal to I1 plus I2. Remember, we are considering in absence of interference phenomena. That must be equal to A square plus A square, that is 2A square. Since we have to write this, that Y1 equal to A sine omega t and Y2 is equal to A sine omega t plus delta. When the two light waves from coherent sources interfere for constructive interference, the maximum intensity will be I max, that's equal to A plus A whole square. We can write that will be 4A square that we have previously seen. Similarly, for destructive interference, the minimum intensity will be I min, that will be A minus A whole square, that will be 0. So the region is dark. But from the equation above that I have previously defined, we have I equal to, what we have, I equal to 4A square cos square delta by 2. So the variation of I with phase difference delta can be shown with a graph. So let me draw the graph for you all. So this is the schematic diagram of the graph for the intensity distribution. So here is the, we have I max value, here we have I min value, and here is the equation that guides this graph. So here this one, minus pi to pi, we have central bright fringe. Then here this one is the first bright fringe, this one is the second bright fringe. Similarly, this one is also the first bright fringe, and this one is the second bright fringe. And these regions are the dark regions, that is the dark fringe. So from this graph, we can say that intensity varies from 0 to 4A square. This is the range of intensity variation. Hence, the average intensity after interferencing. Therefore, I average after interferencing must be 4A square plus 0 by 2. That is 2A square. So this is the average intensity equation. This is also present in the absence of interference. Hence, the energy is conserved. We have seen that in the absence of interference, we are getting the resultant as 2A square, and also in the present of interference, we are getting the average interference or average intensity value as 2A square. Therefore, intensity without interference is equal to average intensity with interference. Therefore, we can say energy is conserved in interference pattern. That is, energy neither gets created nor gets destroyed due to the formation of interference pattern. Now let us merge into a new concept, that is the theory of interference fringes, where we will be heading into long derivations. So we need a schematic diagram for it. Let me draw the diagram for you all. So this is the schematic diagram of the double slit experiment. You were saying that A and B are the two slits. This is the source, and here the we are locating the interference pattern in the screen. We are observing in this region P. The distance between the origin and this point, we are considering it as small x, and the distance between the two slits we are considering as small d. So from here PA1 will be x minus d by 2. From here PA1 will be x minus d by 2. Also PB1 will be x plus p by, sorry, it will be x plus d by 2. Let's say x plus d by 2. Now from here we can see that bp square will be b1 square plus pb1 square. So we can write bp square, that is, you can see this is a right angle triangle, bp square equal to b1 square plus b1 p square. And also we can write ap square, similarly it will be a1 square, that is a1 square plus a1 p square, that is a1 p square is this line. So from this right angle triangle, therefore bp square minus ap square is equal to, if you subtract this equation from this equation, we'll be gaining like this, capital D square plus x plus d by 2 whole square, this is one term, minus of capital D square plus x minus d by 2 whole square. So what is this capital D? Capital D is the distance from the slits to the screen. So BB1 equal to capital D and AA1 is equal to capital D. So we can write this equation. So continuing this equation here, we can say BP plus AP, that is breaking into formula, into BP minus AP is equal to 2xd. If we simplify this, we will be seeing that a square plus b square minus a square plus b square, we will be getting this. So which implies that BP minus AP must be equal to 2xd by BP plus AP. In practice, point P lies very close to O. So it will be O and it will be O1 here. So point P lies very close to O1 because this experiment is a very small one. So BP we can consider as similar to AP because this distance is very small. So we can consider BP, so BP equal to AP, that must be similar to D. Therefore from this consideration we'll be getting BP minus AP is equal to, what comes the value, 2xd by 2d. Therefore we are getting BP minus AP equal to xd by capital D. This is a very important conclusion that we have arrived to. Remember this conclusion. Now we'll proceed further. So what is the position of maximum and minimum on the screens? So conditions for constructive interference, that is maxima. So for constructive interference, let me write this with a separate color for your better understanding. For constructive interference, the path difference BP minus AP between two interfering waves to reach at P on the screen is an even integral multiple of lambda by 2. That is path difference. So we can write BP minus AP is equal to 2n lambda by 2, where you all know that n equal to 0, 1, 2, like this. Or we can say that x small d by capital D equal to n lambda. Or we can arrive at the conclusion that x equal to capital D by small d into n lambda. This is an important conclusion for the path difference. Here n equal to 0 if for central bright fringe that I have drawn previously, and n equal to 1 for the first order bright fringe, and so on. So simplifying this into the n terms, we can write x n plus 1 is equal to capital D by small d into n plus 1 lambda. So spacing between two consecutive bright fringe or fringe width, what will be the fringe width? We can consider is as beta. So beta must be equal to x n plus 1 minus x n, that is difference between the consecutive bright fringe. That will be equal to capital D by small d n plus 1 lambda minus capital D by small d n lambda. So therefore beta will be equal to capital D lambda by small d. So this is another important conclusion or result that we have arrived. As beta is independent of n, the bright fringes are equispaced. We can assume that. So what are the two conclusions that we have arrived? This formula and this formula. Remember it by heart. For this is constructive interference pattern. Now we'll further proceed to destructive. So for destructive, the path difference BP minus AP is an odd integral multiplier of lambda by 2. So we can write BP minus AP is equal to 2n plus 1 lambda by 2, where you can already remember that n equal to 0, 1, 2, 3, like this. Or we can write x dash small d by capital D equal to 2n plus 1 lambda by 2. Or we get that x dash, it will be x dash equal to capital D by small d into 2n plus 1 lambda by 2. So this is another important conclusion. So now, similar to the constructive interference pattern, if we consider the fringe width for as beta dash, so we can write that it will be x dash n plus 1 minus x dash n, that is difference between the consecutive dark fringes. That will be equal to capital D by small d 2n plus 3 lambda by 2 minus capital D by small d 2n plus 1 lambda by 2. Therefore beta dash must be equal to capital D lambda by small d. Hence the dark fringes are also equispaced. So what are the two conclusions that are important? One is this, another one is this one. So this is for the destructive interference pattern. So here we see that the width of the dark fringe is equal to the width of the bright fringes. So both dark and bright fringes are equispaced, And the final conclusion is the width of the bright fringe is equal to the width of the dark fringe. So now after all these derivations, we will straight away move to the last but one of the most important topic of this chapter, that is Newton's ring experiment. So friends, these are the two schematic diagrams we need to understand this process. So this diagram here is the experimental setup for Newton's ring experiment. And this one is the ray diagram of interference beams coming from lower and upper surface of thin films. So these are two important diagrams. And let me explain the experiment of Newton's ring to you all. So when the convex surface of a plano-convex lens, this is this lens, it is plano-convex lens, L we have considered here, with long focal length is placed on a glass plate G that we have considered here, G, this is a glass plate. A very thin air film of varying thickness is formed between the lower surface of the lens and the upper surface of the glass plate. That is, let me mark it with a different color. That is, they have talked about, what I am saying is this portion. We have air trapped in between the lower surface of the lens and the upper surface of the glass plate. Similarly, this is also this region, you can say. So the thickness of the air film increases from their point of contact, that is at this point, towards the periphery of the lens. That is, as we go towards the periphery, that is from this point of contact we go towards this point, the layer thickness increases. Moreover, the points of contact thickness in this air film will lie on circles with point of contact O. If we consider this as the radius, then like circular point of contact will be getting of the air film. So suppose the light from the monochromatic source S, that is from this source, is made parallel by placing it at the focus of the lens L1. So this is the focal length of this lens L1. This is the focal length of the lens L1. I'm getting at F1. So the parallel rays are reflected by a glass plate P inclined at angle 45 degree. That is this one. Let me mark it with a different color for a better understanding. This is the glass plate inclined at 45 degree to the horizontal plane. And so incident normally on the air film between the plano-convex lens L and the glass plate G viewed. The other part enters into the air film and gets reflected at the glass plate at the point C and finally emerges from the lens. So if we magnify this image here, so we are just referring to this point C that again reflects back. So now understanding this phenomena and this experiment, I'll be writing the formulas for you all that you all have to remember. So as you can see, this air trapped or this layer of fluid trapped in between the lens and the glass plate plays a very vital role in Newton's ring experiment. So if mu is the refractive index of the medium between the lens and the plate, so if we draw a ray diagram like this, let this be the lens, this be the glass plate, and we draw a triangle, make it meet at this point, and let this height be t and this be r. So this will be r minus t. Let this point be a, named as a. This radius be r, this be o, and this point be n. And let this point be p, and this be rn. So we can say, since there will be an additional path difference of plus lambda by 2, why? Due to the reflection from the surface of the glass plate that I have shown you here, that is denser medium. The path difference d for normal incidence of the two reflected interfering waves at a distance of rn from O at height t from the glass plate is equal to, we can write 2 mu t plus minus lambda by 2, where mu is the, I have already told, mu is the refractive index of the medium between the lens and the plate. And also we can write cos r equal to 1 for normal incidence. This case is for normal incidence. Now at point of contact, that is this point, t will be equal to 0, as you can see. So the path difference is lambda by 2. Hence the central spot is dark. Therefore for bright fringe the condition will be, therefore for bright fringe the condition will be 2 mu t is equal to 2 n plus 1 into lambda by 2. So this will be the condition for bright fringe. Similarly, for dark fringe, the condition must be 2 mu t. Here it is 2n plus 1 lambda by 2, and here will be n lambda. So what we have got here, we have got two important conclusions. One is for bright fringe, another is for the dark fringe. Also we can write the value of t, which comes out to be rn square, that is this value square, by 2 into capital R. This is the value of t, that is the height. So friends, from here we can also obtain the formula for diameter of nth ring, that is the circular rings around the lens. So what will be the formula? It will be dn whole square equal to 2 into capital R into 2n plus 1 to lambda by mu. This is for bright fringe, and dn square equal to 4 into capital R n lambda by mu. This is for dark fringe. So let me write that down for you all. So this is for bright fringe, and this formula here is for dark fringe. We can also calculate lambda from here. So what will be the value of lambda? It will be d n plus m whole square minus dn whole square by 4 into m into capital R. So this is the formula for wavelength. here in this equation, dn plus m is the diameter of n plus mth ring. So from here we can also find out the refractive index of liquid by the Newton's ring method. So what will be the formula for it? It will be mu equal to dn plus m whole square, that is the diameter of n plus mth ring, minus dn square by dn plus m square minus dn dash whole square. Here it will also be the dash. So this is the formula for refractive index of the liquid. So here, after all these, we also have the formula for taking out the fringe width. So as previous, we are considering it as beta. So beta will be equal to dn plus 1 minus dn by 2. So that will be equal to r lambda by dn. So this is the formula for fringe width. So friends, after memorizing all the formula, let us come to a conclusion. An important question that comes mostly in the exams, that what will happen if we use white light. So if we use white light as incident light, then the central spot will be black, surrounded by a few colored rings, and beyond this the general illuminations due to overlapping of different colored rings will be observed. So let me write that down for you. So this situation will occur if we use white light in place of monochromatic light. The central black spot will appear, that is the central spot will be a black spot. Then it will be surrounded by few colored rings, that is the central one will be a black spot. Then it will be surrounded by a few colored rings, and then number 3, beyond this the general illuminations. Why the general illuminations? Due to overlapping of different colors will be observed, because white light is composed of various colors. So that's all for the topic of interference, and next we will continue with the topic of diffraction, that is the second part of this module, that is module 2. So that is all for this video. Thank you.